In this presentation, I'm going to be demonstrating the method that we've discussed in the introduction to efficient 3D machining. So first of all, I'm going to go ahead and open an existing file, and I'm going to navigate to the rose and crown.crv 3D file. I'm going to highlight it and I'm going to click open, and this should now open up my already created 3D sign. So if you just go into the 3D view, first of all, what we will do is we'll take a look around our sign itself. So as you can see, this is our 3D sign. So we have a nice 3D border, we have a few 3D pieces of Clipart that have been placed, and we've also created some text on here also in 3D. So let's just take ourselves into the modeling tab just to get a feel for what we're dealing with here. So as you can see, this is our text. So this has been created by the text tool, and then what we've done is we've come into the modeling tab and we've created the shape from the vectors to create our VCarve look in the text. So what we're going to do first of all is we're going to fully machine this in pure 3D. We're going to take a look at how long that actually takes, and we're then going to see some of the downsides to fully machine this in 3D. So let's go over to the Toolpath tab and let's begin by setting up our material. So as you can see, we're working with 1¼ inch thickness material. We've got our XY datum in the lower left, and you can see that our model thickness is exactly 1¼ inches thick as well. Obviously, just check through your rapid Z gaps and the home start position, and if we're all okay with that, you just simply press OK. So once we've set up the material, we can go ahead now and start creating ourselves our toolpaths. So first toolpath I'm going to create is the 3D roughing toolpath. So I'm going to come up to this icon here and I'm going to click on that. And then what I'm going to do is I'm going to select my tool. So I'm going to select my 1/4 inch end mill, as I'm going to use that to rough out this piece of material. And I'm just going to make sure that my feeds and speeds are all correct for my machine. So I'm going to be running at a feed rate of 200 inches a minute, and I'm having a pass depth of 1/4 inch. And if I'm happy with that, press OK. So for the machine limit boundary, I'm going to choose the model boundary, as I want to cut out everything here. And I'm going to leave a machine allowance of 0.03, so I'm just going to leave that as it is. And then as the roughing strategy, I'm going to choose the Z level rastering across X, and then profile last. And if I'm happy with that, just simply press calculate. And this will then send us into the preview toolpath form. So we can go ahead and preview that toolpath. Now one thing that we need to think about when creating our roughing toolpath is the actual finishing toolpath tool itself. So if I'm going to be using an 1/8 inch bullnose tool for the finishing toolpath itself, I need to start thinking about the step down that we've got here on this roughing toolpath. As if you look down the bottom right here, you'll see where it's got the Z level, it's got at the minute it's down by 1/4 inch. This is the top of the material as it says 0, and it drops down to 1/4 inch. Now you've got to think that this small 1/8 inch tool that I'm going to be using is actually going to be cutting into that material, so it may be too much of a step for our finishing tool. So what we can do is we can simply go back into our toolpath. So I just double clicked on the toolpath name itself, and then rather than actually change my parameters for my tool permanently, I can go ahead and just edit them temporarily by pressing this edit button here. So I'm just going to change this to a pass depth of 1/8 inch, as I know I have a step down on my 1/8 inch tool at 1/8 inch. So I'm going to be happy with that, so I can click OK, and then all I need to do is just check that the options haven't changed and then press calculate again. So if I just reset that preview now, you'll see that we'll have a much more user-friendly roughing toolpath for our finishing tool, like so. So you'll see it drop down in stages 1/8 inch. So that's going to be a lot more easier on our tool. So once we're happy with that, we can close the preview toolpath form, and then we can go into the finishing toolpath. So I'm just going to click the icon, and I'm going to first of all select my tool. So we said that we're going to use an 1/8 inch bullnose tool. So I'm going to select that from my tool database, check over the parameters. You'll see again it's going to use the same feed rate at 200 inches a minute. It's going to click OK, and we're going to choose the same machine limit boundary. I'm going to choose a boundary offset. So if we want to try and get as much of this rounded edge of our border, we need to create an offset which is at least the radius of the tool. So I'm just going to go slightly over that. So I'm going to go to 0.08 of an inch, and then I'm just going to click calculate, and that's going to then calculate my finishing toolpath for me. Now, this sign itself is 30 inches wide and 20 inches tall, so it's quite a big sign, and this is going to be quite a long toolpath to run on the machine. So you'll see that's why at the moment the software is also taking a long time to calculate this toolpath, as it's a very small tool and it's quite a large work area. But we need to use the 1/8 inch tool to get into all the detail on our 3D pieces, and also for our text as well. So what I'm going to do now is I'm just going to pause the video, and I'm going to resume the video once this is calculated. So the software has just finished calculating the finishing toolpath, and we can now go ahead and preview that toolpath. So let's just go ahead and run that in the simulation, and you'll see this is what we will end up with. So if we take a closer look on inspection, you'll see that we've got a nice finish around everything. Now the text, you can see that if we did V-carve this, we'd have much more of a nicer point at the center of each of these characters. Some people may be okay with that, that's not a problem, but obviously for those that do like the nicer quality finish of the V-carve in text, we could obviously have V-carve this. Now this is what we need to actually start thinking about when we're thinking about trying to 3D machine more efficiently. So we need to look at this and think, this flat area here, we could machine that with a pocket. This text, we could use a V-carving toolpath, and the rest then we could 3D machine with a 3D toolpath. So essentially we're only going to be machining the 3D objects only with the 3D toolpath. So some of the downsides to 3D finishing is that if we just go to our 3D model without the preview, so you'll see that this, if you look at the depth down here on the bottom right here, you'll see the Z depth is a constant 0.3334 all the way through this flat area. Now if we look at our preview on the toolpath, you'll see that this varies constantly throughout the whole. So you'll know that you're never going to be guaranteed the full flat surface. So that's going to require hand finishing on that as well. So what we can do now is we can see how long these toolpaths would take to run on our CNC machine at 200 inches a minute. So I'm going to close the preview toolpath form. I'm going to go into the summary of all toolpaths, and you'll see that's going to take just under 9 hours to machine. So the roughing itself is going to take 2¼ hours, and the finishing is going to take 6¾ of an hour, and that's based upon running our machine at 200 inches a minute, which is quite fast for a machine. So let's go ahead and close this now, and what we're going to do is we're going to take a look at our model and see what we can do to speed this up and make our toolpaths more efficient and give us a nicer quality finish as well. So let's just turn off all the toolpaths so we can get a better look at our object. So what I'm going to do is I'm going to create a pocket around all of my 3D objects to machine the majority of this flat surface away, and then I'm also going to V-carve this text rather than 3D machine it. And then I'm going to just create vector boundaries around each one of these 3D objects, including the border, and then just purely 3D machine that alone. So to start with, I'm just going to go into the 2D view, and I'm going to go back over to the drawing tab, and what we can do is, if I just click F on the keyboard, that will center my work area for me as well. So the first thing I'm going to do, as I'm going to be V-carving my text, is I'm actually going to turn off my text component within the component tree. So you'll see that in the 3D view, we've no longer got our text there. And that's obviously because if I come to rough and 3D toolpath in a short while, it will pick up the text as well. And obviously I don't want it to pick that up at all. So that's why I'm going to turn that off for this. Now I'm just going to go into the 2D view, and I'm just going to go ahead and select my 3D pieces of Clipart first. So I'm just going to select one, hold shift on the keyboard and go around and select the rest of the pieces of 3D Clipart. And when I've done that, you see that they're all highlighted in the component tree, and then we can just go ahead and press this button, which is going to create us a vector boundary around the selected components. So if I just press that, you'll see that now we've got vectors that run around. So we've got those vector boundaries nice and simple. So the next two boundaries that I need to create is one for the outside of our border sign, and also the inner border vector as well, as I want to create one vector here for the pocket, because I want to pocket up to the start of the border shape. So how I'm going to do that is I'm going to utilize some of the drawing tools. So all I need to do is deselect all of the components and then select the panel itself. So you'll see that in the component tree that's been selected, and also in the 3D view that's also now highlighted in red. And all I'm going to do is I'm going to utilize this tool here, which is the Trace Bitmap tool. Now if I just go into that, and you'll see that these are the options here. We get a type of tracing to use, so we can choose color or black and white. I'm just going to use black and white for this, as the 2D representation of any 3D model is black and white, so it's going to be nice and easy to pick that out for us. And all I'm going to do is just scroll this little icon here. So you'll see that that's the max. That's now gone across the whole thing. So if I just go back one and just go back a few more steps, I'm going to choose it to create our vectors here. So if I just press the preview button, you'll see that then now we've got an internal and external border shape. So I'm just going to click apply, close, and I'm just going to delete the outer vector there and actually just create this one using the modeling tool itself, using the create vector boundary from selected components, like so. So now we've got all of our vectors that we need to create our toolpaths. So what I'm going to do is I'm going to go back over to the toolpaths tab and start creating my more efficient toolpaths. So the first toolpath I'm going to create is the 3D roughing toolpath. Now rather than create a new toolpath, I'm just simply going to double click the one I've already got and just edit the parameters for this one. So I'm going to now select my new vector boundaries. So an easy way to do this is to first of all select them all. So I'm going to press Ctrl and A together, and that's going to highlight all my vectors. And I'm going to hold Shift down and deselect any of the vectors that I don't need. So I need these two for the border, and I need the rest of these for the 3D shapes. The only one I don't need is the one for our text. So whilst holding Shift, select the rows and crown text, and then we've got our vector boundaries. Now just remember to make sure that we've got the selected vectors as our machining limit boundary, as you can see here. Specify our machine allowance. I'm just going to leave that the same as 0.03 as we had before, and the rest of the options should be exactly the same as well. So I'm just going to press calculate, and that's going to recalculate this toolpath for me. So if I just reset the preview and preview that selected toolpath, you'll see our new roughing toolpath. Now you'll see that this hasn't been roughed out, which is the centerpiece, because we're going to create a nice pocketing toolpath for that. So next I'm going to go ahead and create me my finishing toolpath. So again, just going to double click the finishing toolpath, I'm going to go onto the 2D view to see what vectors I've got selected. So you can see the ones that I had selected for the roughing are still selected. So all I need to do for this toolpath is simply change the machine limit boundary from model boundary to selected vectors, like so. And again, we can keep that boundary offset as to achieve those nice rounded corners on each one of our 3D objects. So again, the only thing we need to change is the machine limit boundary, and simply click calculate, and that should now also calculate in the software a lot faster than having to calculate the whole 3D shape as a whole, like so. So if I just go ahead and just preview that, you'll see that we've now got our 3D shapes in order. The only thing that we need to do now is create ourselves that pocketing toolpath. So to do that, I'm just going to simply close the preview toolpath form, select the pocketing toolpath there, and then we can go ahead and specify our depth. Now if we're not sure what depth we need to actually cut down to, what we can do is first of all select our start depth to be the top of the material, like so, highlight the cut depth as you can see here. Now if we look at the option down here, we can see what Z depth our model is. So you can see that our Z depth we need to cut down to is 0.3334 of an inch. So that's how we can go ahead and get our cut depth for our pocket. Then we can go ahead and choose our tools. So I'm actually going to use an 1/8 inch end mill for this. Now you might be thinking, why would I want to be doing that? Now first of all, as you can see, we haven't got an 1/8 inch end mill, so I'm just going to go ahead and copy our 1/4 inch, change the parameters in here. Now the reason I'm going to be using an 1/8 inch end mill is because I'm also going to use this option here, which is the use large area clearance tool option as well. So what that's going to do is enable me to use a larger tool to begin with to hog away the majority of the material, and then tidy up afterwards with the smaller end mill. So I'm just going to change the pass depth to an 1/8 of an inch as well, and then I'm happy with the rest of the options, so I'm just going to click apply and then OK as well. Now to enable this option, just simply select this checkbox here, choose your tool. So as it's suggested, I am going to use the 1/2 inch end mill tool, and I'm just going to change the feed rate to 200 as well, and then we can specify the rest of the options. So I'm going to keep the clear pocketing strategy as rastering, and we can just keep everything else the same. Now I'm just going to go into the 2D view and make sure my suitable vectors are selected. So I only want to basically pocket around the inside of this border and around the 3D shapes. So all the vectors that I've selected are okay apart from this outer one here. So I'm just going to hold shift and click on that to deselect it, and all the rest of the vectors are perfect. So all I'm going to do is click calculate, and that'll then calculate my toolpath. So that you'll see that we've got two toolpaths that have been created. Now this is because we've obviously got different tools. So the one with clear in square brackets is the one with our 1/2 inch end mill. So if we just preview that, you can see what that's going to do. So you can see that's going to hog away literally the majority of that material. The only pieces we're going to be left with are these tiny areas here where the 1/2 inch tool wasn't able to actually fit. So that's why we run this second toolpath afterwards, which is going to be with the 1/8 inch end mill, and then just simply tidy that up. So the last toolpath that we need to create now is our V carving for our text. So I'm going to close the preview toolpath form. I'm going to go to the 2D view. I'm going to highlight only my rows and crown text. I'm going to go to the V carving and engraving toolpath form, and I'm just going to go ahead and select myself a tool. So I'm going to select a 1 inch 90-degree V bit running at 200 inches a minute. Now the reason why I keep mentioning the feed rate is just to show you an equal distance, is just to show you that it's equal on all the toolpaths. So if I just go ahead and click OK, and the rest of the options should be the same apart from the fact that I want to project this toolpath onto the 3D model. Now if I didn't do that, I can show you what will happen. So I'll just go ahead and preview that, and you'll see that we've barely scratched the surface on that, as you can see there. Now this is because the toolpath starts at 0 and probably finishes before it gets to here, which is 0.3334. So that's why we need to project this onto the 3D model, as the software will work out exactly what height it needs to be at to carve the text onto this surface. So just simply check that option there, calculate it again, and then just preview that, and you'll see that now we've got our nice V-carved text. The only other toolpath that we're missing is our profile cutout, so that can quickly be created. So just select our outer vector, go to the profile toolpath. We want to cut through the whole of the material, so I'm just going to type in Z equals there, and that's going to bring up the total depth of material being 1 1/4 inch. Choose our most relevant tool, so we can use a nice big tool for this, so we can use less passes. So I could just use the same 1/2 inch end mill that we've already used, and just press OK. And we're going to run it around the outside of the vectors, and we can add tabs if we want to. I'm going to imagine that we've got a vacuum hold down system, and I'm just going to call this profile cut out, calculate that, and preview. And to get rid of the waste material in the preview, we just need to double click the pieces where we want to delete, and that'll just leave us with our preview of our sign. So what we can do now is close the preview toolpath form and go into the summary toolpaths and see if we've actually saved any time. So as you can see, the total machine time now has been brought down from 9 hours to 5 hours and 50 minutes. And this gives you a breakdown of what each of these toolpaths are doing. So if you remember last time, we nearly spent 7 hours just finishing the project itself. So here you can see it's only going to take 3 hours and 32 minutes. And the roughing is also halved as well to 1 hour and 20 minutes. And this is all based on the 200 inches a minute that we set in the tools. Now there is one more option available to us to enable us to machine this 3D project more efficiently than what we have done at the moment. Now what may that be, you may ask? Now if we just take a look at our 3D object, there is one thing that we could change, and that would be the border. Now you can see at the moment we've got a nice 3D shaped border. Now what we can do is that we could actually take advantage of shaped cutting tools to actually recreate that border for us rather than having it 3D machined. Now that will also take down the 3D machining time again quite dramatically, as that is quite a big chunk of 3D machining, and it will also be done very quickly using a profile toolpath. Now we don't need to create any more vector boundaries than what we've got at the moment, as we've got all the necessary boundaries for that. The only thing that we need to do for this is to add ourselves the shape cutting tool to our tool database. Now when we purchase these type of tools, normally the manufacturer will give us access to a vector that will that we can use to add the tool to our tool database with. So if we go over to the drawing tab and just go into the layers, I'm just going to go ahead and turn on the tool shape, and that'll reveal the vector that we got given via the manufacturer. So if I just zoom in a little, you'll see that this is the radius shape of our tool. So to add this to our tool database, all we need to do first of all is select the vector like so, go to toolpath and then click on tool database. Then at the bottom you'll see that we've got a load of options. Just simply click new, select the tool type. So this would be a form tool. So if we just select the form tool, you'll see straight away that this has then ultimately measured the diameter of the tool, and it will also display the shape of the tool that we will be using, like so. And you can see the pass depth that we've got here. That's automatically been calculated by the software. So the only thing that we need to do is simply add in the rest of the speeds and feeds. So spindle speed, I'm going to put as 12,000. I'm going to choose the feed rate to be 200 inches a minute. So if I just change it to inches a minute, then just change it to 200. Plunge rate again 30 as we've chosen for the rest of the tools. Now I'm just going to choose step over of 10%. So I'm just going to go up and choose 10% there and click apply and then OK. So that's then added that tool to our database. So I'm just going to turn off that layer now, as you can see, and I'm just going to press F on the keyboard to zoom to fit our screen. And then all I need to do is go ahead and create that toolpath. So if I just go back to modeling, I can then use this button to switch back to the toolpath tab, like so. And all I need to do now is select the outermost vector, as that's the vector that we're going to use to create our profile toolpath with. So if I just go ahead and select the profile toolpath and set the maximum cutting depth to be the depth of material, which is 1 1/4 inches, I am then going to go ahead and select my tool. So I'm going to open the tool database, I'm going to go down to form tools, and you'll see that this is the form tool that we just created. So I'm just going to go ahead and select OK on that. Now in this case we are going to machine on the outside of the vectors, but we also do need to take into account the fact that if we look at this tool, you'll see that we do have a flat shape in the middle. Now I've measured how wide that flat shape is, and it's exactly 1/2 inch. So we need to make sure when we're actually thinking about creating this profile toolpath, we do need to take that into consideration. So we may need to offset our tool away from the vectors that we want to machine. So to do this is quite simple. I'm just going to click OK again on the tool, and where it says allowance offset, we're just going to first of all type in the diameter of the tool. So as you can see, if you read that here, you'll see that that's the diameter. So I can just read that in. So 3.7459, and then I'm going to divide it by 2, as I'm only going to use half the actual diameter of the tool. So just divide that by 2, get that. And then I'm also going to take away half of that center flat of the tool itself, which is going to be 1/4 inch. So I'm also going to take away 1/4 of an inch on that as well, and that's what our allowance offset is going to be. Now we need to make sure that this is a negative offset allowance. So if I just type minus in there, everything else should work out itself. So I can scroll down now and I can go ahead and just calculate this toolpath, and then we should see, if we reset the whole job, we should end up with the exact same shape as, or something similar to, the border that we got in the 3D toolpath. So let's just go ahead and preview that toolpath. You should see that we've got something quite similar to the border that we desired when we modelled, or that was in the 3D model itself. So the only other changes that we need to make to our toolpath is just change what we are 3D roughing and finishing. The pocketing and the V-carving can stay the same. So if we just close the preview toolpath form and go back into the roughing toolpath and then select the 2D view, I'm just going to go ahead and then reselect some vectors that we only want to 3D rough and machine. So as we no longer need to 3D rough the border, I'm just going to hold shift down and deselect the inner and outer border vector shapes like so, and the rest of this should stay exactly the same. So all I need to do is calculate that, and as you'll see, we'll end up with something that's a lot less rough this time. Then I'm just going to go ahead into the 3D finish again and just deselect those exact same vectors like so, and everything else should stay the same. Calculate that again. So now we are only 3D machining these 3D pieces of Clipart. So let's go ahead and preview that toolpath as well. So there we have it. The only things that we are 3D machining now are our 3D objects. So I should be able to now just run our pocketing toolpath. So here's the clearance, and then the cleanup of the pocket, and then the V-carve text. And if I just double click the waste area, we now have our fully finished 3D object, which has been efficiently machined using a combination of 3D toolpaths and 2D and 2.5D toolpaths. And let's go take a look at exactly how much time we have saved this time. So if I just close this preview toolpath form and go into the summary toolpaths, you see that now we've shaved down the machining time to a total of 2 hours and 40 minutes. Now we will have to add some time in for tool changes, of course, but this shouldn't be anywhere near the 9-hour total time that it took to purely 3D machine this sign. So as you can see now, the 3D roughing has been taken down to just 10 minutes, and the 3D finishing itself is just an hour and a half. The rest of the time is taken up by the rest of the 2D and 2.5D toolpaths. So you can see in this case it is really worth thinking about 3D efficient machining and using that combination of 2D, 2.5D and 3D toolpaths. Another interesting technique to be aware of is rest machining, and that is another video that comes under this efficient machining of 3D models, which you can also go and watch after this as well. Thanks for watching.